Hey, welcome back to Engineer's Workshop. So it's middle of the week. I had a little bit of a break from the heat, but not today. It's back to being kind of a scorcher. So I'm going to try to get a little bit done before it gets too oppressive. And my son got the spacer pieces all welded up. So before I show you that, I want to brag about, let you see the example of the good welder that I have access to for absolutely free. All right, so let's take a look at this thing and see how we're going to hold it for the next set of operations. All right, so this print is basically one-to-one. So you can see if I line things up here on the tail end that we've got maybe about 3/16 that has to come off of it in total. We're going to be taking a little bit off of here to true things up. And then the remainder can come off of this this end down here, which is thicker. Now I did take a cleanup cut on this OD, so if I grabbed the small end with the 4-jaw chuck, then I could essentially turn this, or indicate on this and turn almost all the way up to the very end of that. So let's maybe, well, I'm going to see how far the chuck jaws stick out if I just grab the OD and then use this center to start. This setup seems reasonable. So what I'm going to do initially is just touch the surface, knock any high spots off the weld, and then come up close to the chuck jaws. And then I'll take a few more passes until I clean up the entire surface. Let me get this hard stop set. Okay, I'm not going to be trying to make this a perfect cylinder. If his welds fall slightly under the surface, you saw how deep he got that penetration. He did a root pass, melted things together, and then did a filler pass, brought it up almost flush with the outer surface. So I don't need to do anything special here other than to get it concentric. So let's take a cleanup cut. He's going to take another 5. Just curious how much undersize of 2.5 we went. 482, so that's not too bad. Went under by not quite 20 thousandths. One inch 225. And we've got to come down to 1 inch 182. about 10 thousandths over at this point. By the numbers, that should fit. With about a 1.5 to 2 thousandths clearance. That's good, and I can't really get any play. I think that's a good fit. Now, without removing any more material, I want to get rid of the radius in the corner. And for this, I'm going to have to keep the tailstock out of the way. Tiny area here that didn't clean up, but we're going to be parting off most of that anyway. So I'm well seated. I'm going to go ahead and start facing this back. No sense being slow about this. We got a long way to go. I'm going to increase my feed, and I'm going to increase my depth of cut, 40 thousandths. That looks aggressive. Let's see where we're at on length. We're at 660, 3.665, so 10, 20, 30, 40 thousandths more. Let's do 30 in one shot and do a cleanup. Now we should be left with about 10 thousandths to go. Right at 9, so last pass. If you remember, I had said that I think the existing pulley acts as a lead-in for the belt. So I want to put a very shallow chamfer on that edge so we don't wear that timing belt away. It'd be a little clearer if I showed you what I was doing here. So you can see I got a very shallow lead in there. Well, you'll have to use your imagination and pretend I just drilled that out because I forgot to hit record. So we punched this out to about 3/4, which is big enough to fit our boring bar in. Now we take this hole up to the size that fits the pilot diameter of the mounting bolt for the timing pulley. Right, I'm looking down into the front end of my son's Spitfire with the TDI conversion. So this is our crank pulley with the timing belt drive, and the spacer, you know, the harmonic balancer would have gone directly on this piece. That spacer is going to stand it out to about here, and he took the accessory drive bracket off. Problem I have is I can't get mics, my 1 to 2 inch mics on that surface, because all of this, you know, perimeter here and the belt and the pulley, you know, stand out as far or farther than that, and so the barrel of the mic, I just can't get it square on there. I mean, I got a measurement of 1.184.5 approximately, but I'm going to try with the good Starrett digital calipers and see if I can get the same measurement or something close, because coming at this at an angle is the only way I can see that I'm going to be able to get the jaws onto this and get an accurate measurement. Even with these, it's going to be difficult. I can lock this down once I well, 1.1805. So I had 1.184.5. So that got me a little tighter. So 1.182. Let's try this way. Actually can get 1.177 right there. I think that's the dimension, 1.177. 1.1770. And there is the indexing pin between those two bolts. So I'm going to have to put a little recess, a little countersink in the back side. Actually, I think that this is part of the pulley. So the bolt actually isn't the pilot. It's a one-piece pilot standing on the face of the pulley itself. So that should be running pretty accurately. Let's go ahead and open up that counter bore. Okay, we're back over at the big shop. Not air conditioned. It is not a very nice day to be working, so pardon the fan noise in the background. Let's see where we're starting out at. 8275, 828. Let's do some math. Got about 350 thousandths to go. So let's hog away at this. I'm up over an inch, so I'm gonna bring my feed down a little bit and start taking a little bit finer cuts so I get a little bit less spring back. Also shortened up on the projection of my boring bar. That should help as well. .068. Okay, I'm about 50 thousandths away. Slowed my feed down a little bit more. All right, I'm about 5 thousandths undersize. So I'm going to go very gently here. I'm getting 1.175, which is 2 thousandths under. So I'm just going to do a spring pass, see if that removes just a little bit. Go for the mark here, 2 more thousandths. .177 on the nose. So I am not going to try to make that oversize at all. If it's actually a tiny bit of a snug fit, I think that's fine. I don't know if you can see the face of the indicator, but it's looks like it's running within about a 0.5 thousandths on the OD there, towards the OD. So I'm pretty happy with that. If there's any run out in this assembly, it's going to be due to the face of the actual crank pulley. So we're going to have to dismount this now and get set up for the mounting bolts. I accomplished a small but important step here in getting the K&T running correctly again. This switch, I had gone through about 2 or 3 that either didn't work or didn't have the center off feature. Keith Rucker, vintagemachinery.org, sent me a switch. I sent him one of these, so it was a nice trade. And this one still had its factory packaging, sealed 1964 air in there. So now I have correct rotation on the spindle, center off protection, left hand rotation, center off protection. Glad to have that. So I'll be bringing the harmonic balancer spacer over here and setting it up to drill the mounting holes. This is set up with a Morse taper socket. I might just go ahead and leave that in there, put the drill chuck in here, and pop those holes, those 4 holes in each end of the spacer. So that'll be an upcoming project. Well, that's a good stopping point. So we've got the spacer piloted, got the length, got the nose fit here, a little bit of a chamfer, tiny bit, 5 degree, 10 degree belt lead in. So next step is to find my V-blocks and then mount a V-block against this so that I can set it up vertically in the K&T. Do the 4 holes, flip it, do the 4 holes and the alignment projection hole, and we'll turn it back over to my son. So I'm about 3 thousandths under, 2.5 thousandths under 3.625 target. Not a big deal. Well, I hope you enjoyed that. It's nice to make steady progress on a project and not run into any major hiccups. So on to the K&T. You saw that I got the spindle switch replaced, and that is going to be a lot nicer than reaching across the table to get to that auxiliary switch that I put up there. Been up there for about a year like that. Thank you, Mr. Rucker, for sending that switch over to me. It worked out. So stay tuned for the next operations on this spacer, which is the mounting holes, and then that about wraps it up. So I'll have to show you that weird pattern. I'll have an updated drawing for you next time, show you what that mounting pattern is. It's not just 4 holes. But anyway, thanks again for watching. Share it with your buddies. Hit the like button. I want to try to grow the channel, and hope the weather breaks for all you guys around the country. Our hearts go out to everybody in Hawaii that lost loved ones. So until next time, from Engineers Workshop, as always, stay safe.